This evening, I take great pleasure in welcoming prehistorian Dr. Alison Sheridan and osteologist Dr. Angela Boyle. Both Alison and Ange have been involved with setting up part of the Kilmartin Museum, especially arranging the skeleton of the Upper Largy ladies, so respectively. Alison and Ange will be sharing their knowledge this evening on the understanding of the people of the Oban Caves, an archaeological detective story. I've been looking forward to this talk so much that without further ado, I'm going to pass you straight over to Alison and to Angela. Thank you.
Thanks very much, Jacqueline, and I hope you can all hear me. Hello, everybody. Thank you very much for tuning in. This afternoon, we're going to share with you the fascinating story of the people who used and were buried in the caves in and around Oban at various times in the past. As will become clear, it's a sort of detective mystery. Who were these people? Oh, there you go. Who were these people? When were they buried in the caves, and why? And at this point, we need to forewarn you that we'll be showing images of human remains, and we hope that you're okay with that. And also, this is going to be a long lecture. We've got loads to say, so strap yourselves in. What we can say about the people associated with the Oban Caves straight off is that they weren't the stereotypical cavemen and cavewomen of popular imagination. Yes, we have Flintstones, but not the Flintstones. And indeed, this brilliant cartoon by Gary Larson makes a great point. We are not dealing with squat grunting savages, but rather with sophisticated folks who made exquisite artifacts, such as these bone harpoon heads that were found in MacArthur Cave and elsewhere. What Ange and I aim to do in this lecture is to start by taking you through the history of the discovery of and research into these caves. Then we'll take you on a journey through time to see how the caves were used at different times in the past. And then Ange, who is an expert osteologist, will tell you what she and others have found out about the lives of the people who were buried in the caves. But let's start with the caves themselves. As many of you will know, there are numerous caves and fissures in and around Oban, several of which have contained archaeological material. Some, like MacArthur Cave, formed when the sea scoured into the cliffs at a time when the sea level was higher than it is now. And you can see them on the map on the left, the former position of the shoreline. Other caves, including two at Cardingmill Bay, are called fissure caves, formed by the widening of cracks in the rock. Both types of cave were used in prehistory. If we look at the history of their discovery, we know that people have been finding archaeological material in the caves for at least 150 years, as is clear from the evocatively named Cave of the Skulls, Waf nan Cleikian, sorry about the Gaelic, in Cardingmill Bay. The Ordnance Survey Name Book of 1878 records that large numbers of human remains were removed from this big cave a few years before 1870. And tradition had it that these were the remains of 17th century raiders. And while that's highly unlikely, sadly we don't know what happened to the bones that were taken out as a result of this fossicking around. And the cave had been filled in by the 1870s. Another cave that was subjected to unprofessional howking before 1870 was Denolly Cave, where the skeletons of a man, woman and child were found. The developments that were associated with the expansion of Oban in the 1860s to 1880s led to several major discoveries, which were explored by the antiquaries of the day. In 1869, workmen who were quarrying building stone for John Mackay came across a small cave at the corner of Nursery Road and Straven Terrace. Flint artifacts, limpet shells, and bones of animals and humans were found, and these were investigated by the distinguished Edinburgh University Professor of Anatomy, Sir William Turner, who published them in a couple of accounts, including volume 29 of the Proceedings of the Society of Antiquaries of Scotland in 1895. In that account, he reports that the skeletons of a man and a child were found, but in a bizarre accident happened to them, and I quote, "The skeletons were forwarded to me in Edinburgh by steamer, which unfortunately was wrecked on the voyage to Glasgow. As the box was submerged in the salt water for some time before it was recovered, the skulls were so softened and injured that I was unable to obtain a proper restoration of the crania. Many of the other bones of the skeletons were also broken. What you see here, if you can see the screen on the right-hand side, courtesy of the Edinburgh University Anatomical Museum, are some of these bones that were rescued from the sea. At some time before 1877, in the cliff next to the gasworks, workmen quarrying stone to create stores for coal came across a cave containing human skeletons, but sadly these have disappeared. In 1877, further quarrying to enlarge the stores uncovered more archaeological material, including enormous quantities of limpet, cockle, and oyster shells, some sherds of pottery, which we now know belonged to the early Bronze Age, to a cinerary urn, animal bones, and the unburnt bones of a man. Some of these finds were sent to Sir William Turner in Edinburgh. Then in 1890, while blasting rock to make a new warehouse behind the distillery, yet another cave was found. Many cartloads of shells were removed, and animal bones, the remains of at least 8 humans, and artifacts of flint and bone and antler were found, including this antler spatula and a bone awl for piercing. Remember the spatula because we'll be coming back to it later. Again, most of these finds were sent to Sir William Turner. 4 years later, in 1894, near St Columba's Church, workmen quarrying on behalf of a solicitor, Mr MacArthur, came across a large cave, which was then investigated by Joseph Anderson, who is keeper of the National Museum of Antiquities of Scotland in Edinburgh. And it was written up in the same volume of the Proceedings of the Society of Antiquaries of Scotland as Sir William Turner's paper. The workmen had in effect blasted off the roof of the cave. Anderson's excavation was able to determine the stratigraphy of the deposits in the cave. He first came across a black layer of earth containing bones of animals and humans. Below that were the remains of 2 separate shell middens separated by a layer of gravel. This suggested activity in the cave at different times. The finds from the shell middens included animal bones, shells, bones of large fish, crab remains, worked flints, hammerstones, and various artifacts of bone and antler, including 2 complete and 5 fragmentary magnificent harpoon heads of red deer antler, plus bevel-ended tools associated possibly with the exploitation of limpets. We'll be coming back to those later. The next cave to be discovered was that at Drumvargi, which was found in 1898 during quarrying to make houses for municipal workmen. This was excavated by local antiquaries Dr John Munro and Dugald MacIsaac, with the results being published by Joseph Anderson. This was on a ridge that would have been on the shore during Mesolithic times, and it's described as being more of a rock shelter than a cave. It contained evidence for the exploitation of marine resources. There were shells of limpets, periwinkles, oysters, cockles and pectins, crab claws and some fish bones. And there were 2 fragmentary bone harpoon heads, this time with barbs just along one side, not 2 sides. There were also huge numbers of bevel-ended and bone tools that could have been used in exploiting limpets. Very few animal bones were found and no human bones. There was then a long period of over 80 years when no new cave sites or rock shelters were found in the area, but this was all to change in May 1984, when Kenneth Connock of the Lawn Archaeological and Historical Society was called in to investigate a cave at Rascully on the Glenshellach Road on the outskirts of Oban that had been discovered when a mechanical digger was removing scree from a cliff to enlarge the area of flat ground around a newly built house. His excavations, which were promptly published in 1985, showed that there was a layer rich in human remains. There were some 2,000 fragments, weighing about 17 kilograms overall, and thought then to represent at least 24 individuals. Below this, but still with some human bones, was a layer containing marine shells, animal and fish bones, and carbonized plant remains. The only artifact found was a small flint arrowhead, thought to be of early Bronze Age type, but sadly the current whereabouts of this are unknown. The Society were also involved in another rescue excavation, this time in Carding Mill Bay, when Kenneth Connock was called in when a fissure cave was found during house building. Both human remains and a shell midden deposit were found. Two of the skeletons, an adult woman and a baby, a juvenile, were found in a kist, along with an early Bronze Age food vessel pot that you can see here, which dates this deposit to around 2000 BC. Below that, other human remains were found that must have been buried in shallow graves dug into the shell midden. Cowrie shells, some perforated to be worn as beads, were found in these midden deposits. Then, between 1991 and 1993, again as a result of earth-moving activities, another fissure cave was found 15 metres away at Carding Mill Bay and was excavated by Clive Bonsall from Edinburgh University. And this cave, which is called Carding Mill Bay 2, contained two layers of shell midden deposits and some human remains. The upper level of midden was associated with the bones of domesticated animals, as food remains, and Neolithic pottery was also found. Finally, in 1992, Clive Bonsall excavated not a cave site, but an open-air Mesolithic camp at Lone Moor. No human remains were found there, however. Overall, then, these sites in this small area of no more than 4 by 2 kilometres constitute an incredibly important set of finds. And for all we know, there may well be more sites out there waiting to be discovered. They're important not only for the shell midden material in them, but also for their human remains, which have been found in 9 of these caves and which survive in museum collections for 6 of those sites. Naturally, these spectacular archaeological discoveries have attracted a lot of research over the years, and even before the advent of radiocarbon dating, it was realised that some of the finds were very old indeed, belonging to a period before farming was a way of life in Scotland. In 1940, an American archaeologist named Hallam Movius, who had excavated Mesolithic or Middle Stone Age sites in Ireland and was comparing the Irish evidence with that from Scotland, coined the phrase the Obanian culture to describe the semi-nomadic strand-looping lifestyle of the hunter-fisher-forager groups on this part of the coast, the west coast of Scotland, who had left behind their harpoons and their other distinctive tools and the remains of the fish, shellfish and wild marine and terrestrial mammals that they had cooked and eaten in the caves. A few years later, in 1954, the influential archaeologist Armand Lacaille further developed the idea that this was a distinctive regional group who, unlike other Mesolithic groups of hunter-fisher-foragers elsewhere in Scotland, did not use tiny stone tools called microliths. So Oban was put firmly on the archaeological map, and generations of students learned about the Obanian culture. The next development in research on these caves came in the late 1980s and 1990s with the radiocarbon dating of both bone and antler artefacts and of human remains. Much of this work was undertaken by Clive Bonsall, who discovered that one of the harpoon heads from MacArthur Cave is around 7,500 years old, dating to between 5730 and 5480 Cal BC, and placing it in the late Mesolithic period. He also dated this harpoon head from Drumvagi rock shelter and found that it was around 1500 years earlier than MacArthur Cave. And you can see the radiocarbon date there. In other words, it's around 9,000 years old and belongs in the early Mesolithic. But other objects from the caves were found to be quite a bit later. An antler bevel-ended tool from Carding Mill Bay 1 was only around 6,000 years old, dating to the final part of the Mesolithic period, while one of bone from the same site, around 5,500 years old, dates to well within the Neolithic period, when people had been farming in the area for at least 8 generations. Later still, and belonging to the Chalcolithic or early Bronze Age, is this antler spatula from Distillery Cave, which is around 4,200 years old. This object was dated for a project by Alan Saville of National Museum Scotland. But the biggest surprises came when the human remains from the caves were radiocarbon dated. Clive Bonsall dated many of the people buried at Rascolli Cave in 1999 and found that they belonged to the Neolithic period, the New Stone Age, with dates ranging from around 3800 to 3200 BC. And since then, many more dates have been obtained for people buried there and in the other Oban Caves, and indeed in other caves in Scotland. And this diagram that you see on the left shows many of the Neolithic dates for human remains from Scottish caves. And when my late colleague Alan Saville dated 4 bones from MacArthur Cave in 1994, he found that they were much later, dating to the early Iron Age, with dates ranging between 750 and 50 BC. Further Iron Age dates for people buried in MacArthur Cave have recently been obtained in connection with an ancient DNA project, and they extend the date range into the 2nd century AD. You can see them in the white bars here. Other kinds of research on the finds from the Oban Caves include Ivan Paillet and Catherine Dupont's work on the beveled pebbles that are traditionally called limpet hammers. It had been assumed that these had been used to bash limpets to dislodge them. But in 1995, Bill Finlayson suggested that they might have been used instead for working animal hides, and others had suggested that they could have been used in knapping flint. Paillet and Dupont noted that these simple tools are very widespread on shell-midden sites in Europe. You can see a distribution map there on the left, and have been in use in Brittany as limpet hammers until the present day. And they undertook experimental and tracewear analysis to test whether the prehistoric examples had indeed been tools used in gathering limpets. They concluded that yes, indeed, these are limpet hammers, with the beveling developing as a result of the stone repeatedly hitting the rock as the limpet gets bashed. As an antler, these had traditionally been described as limpet scoops for getting the meat out. But as Tony Pollard noted in his 1994 PhD about the Oban Caves, you don't actually need a tool when your finger works perfectly well. Instead, it had been noted that many of these tools have a high polish on their beveled end and a greasy feel, and it may well be that these were used for working animal skins in the caves to make clothing. Various other kinds of research have been undertaken over the years, with Professor Clive Bonsall and colleagues applying a forensic approach to the middens, investigating patterns of shellfish collection, which species were collected from where on the shore and when, and also looking at the anatomy of a midden, asking how all of the elements in it got there in the first place, and seeing what can be found out about the environment in the area of charcoal present. This diagram, which you don't need to try and digest, summarizes the various sources of material that ends up in a midden and disentangles what got there by natural causes, say when birds fly in, and what was humanly brought in. All of this research has helped to build a rich picture of how the caves were used at various times. And that's even before we get on to the amazing work that's been undertaken on the human remains over the last few years. But before coming on to that, let's just summarise the picture of cave use at different periods. The earliest evidence of the use of any of the Oban Caves dates back around 9,000 years to 7,000 BC, to the early Mesolithic, as we've seen from the dating of the harpoon head from Drumvargi rock shelter. These weren't the earliest inhabitants of Scotland, though, by any manner or means. There were people using a cave at Kilmelfoot, closer to Kilmartin, down the Argyll coast, from as early as 12,000 BC. That's the late Upper Paleolithic, before the end of the last ice age. And Professor Steve Mithen has been finding a lot more late Upper Paleolithic material on Skye. The Mesolithic people who camped in the Oban Caves will have been small groups of hunter-fisher foragers, moving around the landscape as different wild resources came into abundance. They exploited a wide range of animals and plants, and their diet will have been dominated by marine foods, although they clearly also caught red deer, boar, and various other terrestrial mammals and birds. We don't have to see them as a distinctive culture. Rather, their lifestyle was perfectly adapted to the environment and to the coastal area where they ranged about. Other Mesolithic groups living inland will have had a different strategy for getting their food. Clearly, these people camped in the caves and returned to them repeatedly, long enough to amass sizable heaps of food waste. But the one thing they didn't do in the Mesolithic was to bury their dead in caves, even though Mesolithic groups elsewhere in Britain were doing that. It wasn't until the arrival of farming groups in the area, shortly after 4000 BC, that the caves were used for burial. These farmers won't generally have lived in the caves. They will have lived out in the landscape in houses. There's evidence suggesting occasional use of some of the caves for burial during the Copper Age and the Early Bronze Age. And at MacArthur Cave, there's evidence for Iron Age burial too. And it's worth noting that many of the caves seem to have become blocked by rock falls, perhaps from around AD 500 onwards. But let's look now at the amazing research that's been going on concerning the human remains found in these caves. Various kinds of analyses have been applied over the last 10 to 15 years. Isotopic analysis of carbon and nitrogen isotopes to examine people's diet, osteological analysis to look at illnesses and age at death, etc., analysis of the calculus or the plaque on people's teeth to get additional information on what they ate. But the most stunning results have come from the application of ancient DNA analysis. And before handing over to Ange, I just want to share with you some of the highlights of this DNA work which have been obtained in the last 5 or 6 years. This work has solved a very long-standing debate about how farming became established in Britain and Ireland, showing how this way of life of the basically nomadic or semi-nomadic Mesolithic hunter, fisher, foragers was changed into this way of life based on the production of food by growing cereals and raising domesticated animals, all of which will have to have been brought across the channel, across the sea, from the near continent, from different parts of northern France and northwest France, in boats, probably like this curragh. Some people had tried to argue that this new way of life had been adopted by Mesolithic people who had, somewhat miraculously, travelled to the continent and brought back the domesticates themselves. But I had long argued on the basis of artefacts and monument types that farming was introduced by immigrant groups of farmers coming from different parts of northern and northwest France to different parts of Britain and Ireland, including from Brittany. This makes much better sense of the archaeology that we see it. The evidence for this immigration in this part of Scotland includes a Breton-style megalithic monument, complete with Breton-style pottery, at Achnacribeg to the north of Oban, which may have been built around 4000 BC or shortly after that. It's a two-phase monument with a closed chamber and a round cairn being succeeded by a simple passage tomb, and they extended the cairn to make it sort of pear-shaped there. And south of Oban, at Melie, a very similar monument has been found, and cremated bone from there has been dated, radiocarbon dated, to between 3715 and 3645 BC. Let's get back to the DNA analysis. This slide shows beyond any doubt that farming was indeed introduced by immigrant farmers from the near continent. They brought with them a distinctive genetic signature that goes right back to the first farmers in the Near East around 8000 BC or even earlier than that. And we can also say that they looked different from the indigenous Mesolithic people, who themselves were very dark-skinned. So the farmers were slightly lighter-skinned, but still darker-skinned than Caucasians today, and with differently coloured eyes from Mesolithic people. This slide here shows how different were their genetic signatures from those of the Mesolithic inhabitants in Britain and Ireland. For Scotland, we have genetic data for one Mesolithic woman from Knockcoig on Oronsay to compare with Neolithic farmers. And the isotopic analysis that's been carried out on Mesolithic and Neolithic people has highlighted that they had very different diets, with the farmers avoiding eating fish, shellfish and marine mammals, and instead eating the domesticated cattle, sheep, goats, pigs and cereals that they brought with them from the continent. If you're interested in reading more about the interpretation of the DNA data, I can highly recommend this article by Tom Booth, who works at the Crick Institute. And also there's an entire book about ancient DNA and the European Neolithic that came out in 2022. These results also show that there was, in genetic terms, a near total population replacement of the indigenous genetic signature with that of the farmers, with no subsequent reappearance of the Mesolithic genetic signature. But we have to be careful not to misinterpret this in terms of a wipeout. It was not the case that farmers came and killed off all the locals or gave them diseases to which they had no immunity. Instead, with large numbers of people coming in from the continent to a sparsely populated landscape, and with the farmers having big families because you need your children to help tend the animals and tend the fields, it's easy to see how the Mesolithic genetic signature could get drowned out. And very excitingly, there's evidence from 8 people buried in the Oban Caves to show that indigenous hunter-fisher-forager groups did survive for many generations after the farmers arrived. And indeed, some got together and got jiggy with the farmers and had children with them. And they must have bought into aspects of the Neolithic way of life. So in the west coast of Scotland, it looks as though we've had 2 contrasting but contemporary lifestyles going on for several generations, with some people continuing their Mesolithic lifestyle, as you see on the left, laying out their dead on their shell middens, while other people, the farmers, the French farmers, were farming and building imposing megalithic monuments, as you see on the right. These farmers were also burying their dead in caves, and as we've just seen, there was some interaction between the hunter-fisher-foragers and farmers. And here again, you can see the contrast in their diets, with Mesolithic people on Oronsay having a diet dominated by seafood, while the Neolithic folks had a diet dominated by terrestrial resources, mostly cattle, sheep and pigs, and eating no or virtually no seafood. This is the case with the Neolithic people buried in the Oban Caves. And there's something else that's emerged from the analysis of carbon and nitrogen isotope levels in human remains. While the Neolithic people buried in the Oban Caves did indeed have a diet dominated by cereals and food from domesticated animals, work by Rick Schulting has shown that their isotope levels seem to be slightly different from those of Neolithic farmers who were buried in chamber tombs, even on the coast. Rick is still trying to get to the bottom of this conundrum. But to round off my bit of this talk, here's a particularly interesting case study showing the complexity of relationships between the people living in the Oban area. At Carding Mill Bay 2, as at Carding Mill Bay 1, people were indeed camping out in caves and exploiting marine resources, as well as eating domesticated animals and cereals, well after farmers had first arrived in the area. They deposited their dead here, and here are 2 radiocarbon dates for them, around the middle of the 4th millennium. DNA analysis has shown that 2 of these people, 2 adult women, were related to each other, either as sisters or as a mother and a daughter. And the DNA analysis shows that these people were of mixed hunter-gatherer, forager, and immigrant farmer genetic ancestry. This means that as late as 3500 BC, there were still some indigenous Mesolithic people around. And finally, these people buried their dead the Mesolithic way, on the midden. Elsewhere in the Oban Caves, the human remains are quite a bit later than the middens, so they're above the middens. This is the case at Carding Mill Bay 1, where they must have dug shallow graves into the midden to bury their dead. So without further ado, I'm going to stop sharing and I'm going to pass over to Ange.
Thank you, Alison. Good evening, everybody. It's nice to see so many people here for our second version of our Oban talk. It's worth spending a few minutes on the life and work of Sir William Turner as something of a pioneer. He lived from 1832 to 1916 and was appointed Professor of Anatomy at the University of Edinburgh in 1867. Now, he came to fame in 1857 when he published his nationally acclaimed Atlas of Human Anatomy and Physiology. He was only 25 when he did that, and he was widely regarded as the foremost anatomist of the 19th century. He was instrumental in amassing the collection of the Anatomical Museum in Edinburgh, which comprises more than 1,800 skulls from all around the world. Now, it's worth mentioning as well that his methods in obtaining those skulls would not necessarily be acceptable now. In the 19th century, phrenology was all the rage, science of measurement, all about focusing on the head, taking measurements of the cranium. And it was the main focus of many anatomists' work, including Turner's. Perhaps as a result of this obsession, if you like, with phrenology, it was common practice to only retain skulls and occasionally mandibles. So as you will see, we're actually very fortunate that we have postcranial remains from the Oban Caves, because that was by no means common practice in the 19th century. Most of the material from Turner's collection has now been transferred to the National Museum of Scotland, and it's housed at the Collections Facility in Edinburgh, in Granton. So Turner was tasked with the original analysis of the human remains from Skye Cave, Distillery Cave, and MacArthur Cave. As Alison alluded to, a lot of work has happened, certainly over the late 20th and early 21st century. Most notably, these assemblages were analysed again by Yvonne Hallen in the 1990s, and she published her results in 1994. I recently had the opportunity to assess the entire collection of human remains held by the National Museum of Scotland, and this included the extant material from the Oban Caves. As Alison has mentioned, with the exception of Rash Colley and Carding Bay Mill, all the discoveries were made in the 19th century, and some of the material has been lost. That includes 3 skeletons from Denali, man, woman, and child. Although it would seem that we now know that there are some infant bones from Denali in the collection of Kilmartin Museum, which I would be very keen on pursuing. And it's also suspected that more bones are actually still buried in the grounds of Denali House. They were removed from the cave, taken to Denali House and buried in the garden. So there's an option to possibly explore that as well. Gallenach, 2 skeletons in a crevice before 1895, they're gone. Great quantity, as Alison said, from the Cave of the Skulls. Several from Gasworks Cave in 1870. And infant bones found at Bays of Ganavan in 1906. But today I'm going to focus on the human remains from Skye Cave, Distillery Cave, MacArthur Cave and Dumbarton, because they're the ones that I have analysed that are in the collection of the NMS. So as has already been pointed out, the unfortunate human remains from Skye Cave were sent to Turner by a steamer which ran aground near Glasgow. They were submerged in salt water for a long time before they were retrieved. By the time Turner took delivery of the bones, the skulls could no longer be fully reconstructed, and many postcranial bones were broken. Now, this would have upset him no end because he wouldn't have been able to take his cranial measurements. So when I examined this assemblage, it's about 2 years ago now, there were a total of 89 complete or partial bones. I identified the partial remains of a prime adult male, aged between 26 and 35, and a child aged 5 to 9 years at the time of death, so quite a young child. It's worth emphasising that a complete adult skeleton is made up of 206 individual bones, and a child skeleton would consist of as many as 800, depending on the age. So were the skeletons incomplete when they were discovered? Are there other possible explanations for the missing bones? The image on the left of the slide shows the skull of the adult male. An attempt clearly was made to reconstruct it, rather poorly by modern standards, using staples, glue, and resin. Now that this sort of condition is quite a common sight among the earlier material in the National Museum's collection. It was also common practice to apply animal-based consolidant to the surface of the bones, and this has caused us problems with sampling for biomolecular analyses. I think they're managing to get round those issues now, but they've been far from straightforward. So this adult male had gum disease, quite advanced gum disease, and he had dental calculus, which is calcified plaque. There were no pathologies on the child skeleton. So some of the postcranial bones of the adult male still form part of the collection of the Anatomical Museum at the University of Edinburgh, as Alison said. They comprise the right humerus, left and right femora, right tibia, and right talus. I haven't actually been able to record these in detail yet. What is notable, however, is that the assemblage includes the small bones of the hands and feet, which suggests that both individuals were articulated, or at least partially so, when they were deposited. Turner was able to calculate stature of the adult male using the femur, 5'4", which quite short by modern standards. Both were sampled for aDNA and isotope analysis, and the adult male has been radiocarbon dated to the dates Neolithic.
Oh,
what was that? I heard a strange noise. Okay. Now, still on the material from Skye Cave, when I was recording the bones, you look at each bone individually. As I said, I had identified one male and one child, so it was relatively straightforward to separate those bones, purely because of the morphology and the size of them. So I was looking at the vertebra, assuming that it belonged to an adult male. This is an axis or second cervical vertebrae. However, the arrows indicate sharp force injuries, where a bladed weapon has sliced through the odontoid and the left superior articular facet. Now, that's not something you would expect to see in Neolithic remains. To me, that indicates that the individual was decapitated in life, his head was removed, or possibly at some point after death. I've looked at an awful lot of decapitations over the years, and this is a classic appearance. The presence of this injury therefore suggests a third individual, second adult, but one of later date because of the sharp force injuries that were inflicted, because the weapons would not have been available to carry out this decapitation at an earlier date. This bone hasn't been dated, but I would suggest that it's Iron Age or later, and there are parallels for this type of injury from Sculptor's Cave at Covesea, ranging in date, I think, from the Iron Age through to the 3rd and 4th century. So this is an interesting conundrum, this one. The assemblage from Distillery Cave comprises 371 complete or partial bones. Now, at some point in the past, whether or not they were originally partial skeletons, someone came along and decided to put them all into anatomical element. So I was faced with a bag of all the leg bones or all the arm bones, and that makes the jigsaw really quite difficult. You effectively don't have a picture to work it out by. All the material is well preserved, and there are many complete bones. I estimated that there was a minimum of 5 adults. So one adult male, one adult female, couple that couldn't be sexed. Probable minimum of 3 non-adults in the group as well, 2 younger juveniles and 1 adolescent. The aging of non-adults is relatively straightforward, and it's based on dental eruption and development, alongside the epiphyseal fusion and the growth of the long bones, so we measure length. So it looks like there are at least 2 young juveniles, so they're aged 2 to 6 years, and an adolescent 12 to 17. Presence of a neonate or newborn is suggested by a single partial tumorous or arm bone. Again, sampling has been carried out for aDNA on 3 adults. 2 samples of dental calculus were removed for analysis. Identifiable biomarkers were extracted from the dental calculus, and analysis has demonstrated that seaweed was being consumed. Possibly not surprising given the location. Still on Distillery Cave, metabolic disease is generally the result of dietary deficiency. In other words, a lack of essential nutrients causes nutritional stress in the skeleton. The image on the left shows a condition known as cribra orbitalia, which affects the orbits of eye sockets and is indicative of iron deficiency. The skull is that of a child, and although the image only shows the left orbit, both were affected by the condition. Degenerative joint disease is one of the most common conditions that we see in archaeological populations. It's a chronic, long-standing condition, and it's progressive in its severity. It can be defined as either primary, with no cause evident, or secondary, following disease or a traumatic injury. It is linked to activity, occupation, and, of course, age. The characteristic features are areas of lipping around joint surfaces known as osteophytes, increased porosity, as you see in the image on the top left, and often eburnation, which presents as polishing of the bone. It's a very distinctive change. So the image on the top left is a 6 cervical vertebrae, so bottom of the neck, quite advanced porosity there. And the bottom left is an upper thoracic vertebrae showing moderate osteophytes. The image on the right shows degeneration of the temporomandibular joint of an unsexed adult, and this is where the jaw articulates with the skull. Other interesting features in the Distillery Cave assemblage, lumbar sacralization occurs when the 5th lumbar vertebrae fuses to the sacrum, which is the bone at the base of the spine. This results in a larger and much more rigid bone structure, which can cause back pain, stiffness, and reduced mobility, although some luckier individuals have no symptoms. It's a congenital anomaly of the spine, and it is relatively uncommon. So the image shows the fifth lumbar vertebrae and sacrum of an unsexed adult. The arrow indicates where the fusion between the lumbar vertebrae and sacrum is partial. Part of the disc space has been maintained. And there's also some degeneration of the body of the fifth lumbar vertebrae. Keep forgetting to do my animation. Now, teeth are very resilient and they tend to survive well in archaeological populations. Poor dental health can be linked to diet, oral hygiene, or the lack of it. The health status of the individual and socio-economic status. Ante-mortem tooth loss, decay, calculus, abscesses and gum disease are all commonly seen, and Distillery Cave is no exception. The image on the left shows the mandible of an older adult male with an externally draining abscess caused by dental decay and gum disease, and it's led to ante-mortem tooth loss of the first molar. The image on the bottom right shows an excessive buildup of calculus. Now, this is what happens when you do not brush your teeth. It really is quite it's quite advanced in this individual. Other interesting features of Distillery Cave. Non-metric traits are developmental traits which occur in some skeletons but not in others, and they've been linked to both genetic and environmental factors. One of these traits is squatting facets. Now, these are located on the anterior surface of the tibia or shin bone, just above the ankle. The presence has been linked to habitual squatting, for example, as you see in the statue bottom right, grinding of grains by females. Some infants, however, are born with these traits, so it seems likely that there is a genetic component as well. Turner did identify examples of squatting facets, but those bones are now lost. And you will find that we see that quite a lot in this story. There are a lot of unsolved mysteries. Now, at McArthur Cave, discovered in 1894, it was the first to benefit from any degree of archaeological recording. So some useful detail is available on the location of the bones when they were discovered, and that appears in Turner's publication, which quite clearly indicates that this assemblage was not articulated when it was discovered. There are 103 complete or partial bones in this assemblage. Again, preservation is good, and many bones are complete or partially shown. Again, what is of interest is the fact that all body parts are represented. So this is including the small bones of the hands and feet, which I've already alluded to in reference to other assemblages. And it's important to bear this in mind when we try to think about what process was actually happening in the caves. In this case, the skulls have been bisected front to back, and that would have been carried out by Sir William Turner as part of his examination. Minimum of 3 adults in this group, 1 male, 1 female, and 1 unsexed adult, no children. Skull A is shown on the left here. The damage that you see is post-mortem, so it happened after death. Turner's opinion was that this was probably a young adult male, but when I looked at the skull, I concluded that the indicators that we used to determine sex were contradictory. So I concluded that the individual couldn't be sexed. An adult left ulna from McArthur Cave of some considerable interest. Possible gnaw marks on the shaft there. Comparable no marks were seen on a right rib of a child from Distillery Cave. It's possible that microscopic analysis might provide us with some more information on the interpretation of these marks. Other pathology at Macarthur Cave included a very poorly healed radial fracture, and the radius is one of the bones of the lower arm. Again, degenerative joint disease, which is pretty ubiquitous, really. Lots more ADNA and isotope analysis has been carried out, and I think we do have some results from this. From this, the DNA analysis has identified a pair of brothers, or possibly a father and a son. Moving on to Drumvargi, there's a single partial right tibial shin bone. It's got a surviving length of 60 millimetres, and I've identified it as belonging to a newborn infant. Now, I was fortunate enough to be able to examine this one when I was assessing the NMS collection, and it had actually been misidentified as animal bone. So it really is of quite some significance. It's the only human bone from Drumvargi Cave. It's currently undated. There's not very much of it surviving. Now, it's not mentioned in the original report by Anderson. What's worth perhaps mentioning again is Alison mentioned that Clive Bonsall had obtained an early Mesolithic radiocarbon date on a harpoon from Drumvargi. Nice to imagine that this bone could be earlier. It's very unlikely, and we don't have enough information. We don't know where the bone came from in the cave, or indeed if it came from the cave at all, to be frank. Rush Colley, excavations there, rescue excavations recovered more than 2,000 individually identifiable pieces and very many more smaller fragments. Now, I've only been able to assess a small part of this assemblage, so most of the data is it's derived from Kenneth Connett's interim report. The interim report referred to remains of at least 20 individuals, including children and infants, comprising mostly skulls and long bones. There was no sign of articulation, although some appeared to have been deposited in groups. Now, in contrast at Rajpoli, the small bones of the hands and feet were more poorly represented, and mandibles and teeth were uncommon. What was interesting was that a recent reanalysis of the material found conjoining fragments of human bone coming from different deposits. That indicates that the bones were being manipulated within the cave for whatever reason. Again, degenerative joint disease quite common, particularly in the spine. Top left, you see the glenoid, which is the part of the shoulder joint with quite advanced degeneration there. Slightly less severe in the cervical vertebrae below. There are mild osteophytes on the odontoid process and on the facets. Gum disease and dental calculus were present again in this material, and again the calculus was sampled, but I believe the results were quite disappointing. So it's rarely possible in skeletal populations to determine cause of death, and the Oban Caves are no exception. Most people would have died from acute short-term conditions, and skeletal changes only occur when an individual is suffering from a chronic or long-standing condition. So you've got a bit of a paradox there, so that the people that were really ill for a long time are the ones that survived, and the majority of people would have been carried off by colds and flus and, short-term illnesses. But notable exceptions to this, though, include fatal traumatic injuries, whether accidental or deliberately inflicted, and many are known from the period in question. This is an example from Isbister in Orkney. Now, of course, I have to take you back to the possible decapitation from Skye Cave that I mentioned earlier. Evidence for decapitation, possibly. Was it done after death? It would be really, really good to date that bone. Just quickly on DNA analysis, it's now possible to have DNA analysis done relatively cheaply, inexpensively, and reliably nowadays. Modern contamination is not so much of an issue, and the advances which it leaps and bounds over recent years means that only a tiny little fragment of bone, not even a fragment, dust, is sufficient to successfully obtain DNA. And of course, we're now looking at the total genome. So all genealogical ancestors, details on skin and eye colour, blood type. The bone arrowed in the image bottom middle is the petrous bone, which is generally preferred if it's accessible, because it shows the least likelihood of contamination. 10 genomes, I believe, we have from Skye Cave. Alison will be able to confirm that. Stable isotope analysis again, now very readily accessible, and it's something that we are now doing as a matter of course, really. So just to emphasise, carbon and nitrogen isotopes will provide information on diet. Strontium and oxygen will provide information on geographic origins. Analysis of bones with a fast turnover, like ribs, can provide information on where a person lived in the last few years of their lives. Obviously, as more sampling is done, the baseline data is constantly being added to and improving. The carbon and nitrogen isotope analysis from Skye Cave indicates that they consumed predominantly terrestrial resources. So the information available for the mode of deposition of the human remains from the Oban Caves is limited by the manner in which they were discovered and the material was removed. As I said, some useful data is available from the Cave, and hopefully more will be forthcoming from Skye when that post-excavation at work. The excavator of Skye did suggest that the human skeletal material was deposited after excarnation of the bodies at some other location. And if you remember, I said that small bones of the hands and feet and teeth were in the minority of that assemblage. Certainly the quantity of bone, at least 2,000 identifiable pieces, suggests that the cave was used for the deposition of human remains over a very long period of time. So, excarnation. No complete skeletons from any of the assemblages, but all skeletal elements are represented, including small bones of the hands and feet. Although less so at Rashcollie, they are still there. There's limited evidence for animal and rodent activity. Not a great deal of weathering of the bones, and the peculiar possible decapitation aside, there's no evidence of dismemberment either. Turner's conclusion, his interpretation of the Oban Caves is quite a colourful one, and he suggests that the bodies were the result of intertribal feuds, which doubtless then, as in times not very remote, led to massacres by a hostile clan of members of another clan, surprised and perhaps suffocated by smoke. It may have been at night when resting peacefully in their cave dwellings. So, just to recap, the Mesolithic people of the west of Scotland didn't bury their dead in the caves. Shortly after 4000 BC, with the arrival of the farmers, the caves were used for burial. There's evidence for occasional use of some of the caves for burial during the early Bronze Age and during the Iron Age. So, our current thoughts, bodies were deposited as complete or near complete individuals. Subsequent burials disarticulated the early ones. As the remains became skeletonized, it may be that selected bones were being removed. For what purpose, we don't know. There's still an awful lot more work to be done on the assemblages that we have, and Alison and I are both very keen to find out anything about the material that is currently missing, because ultimately material is never gone without a trace. It will probably turn up. So we've got, there's still a lot to do, but we're excited and look forward to answering your questions and hearing your thoughts. So thank you.
Thank you very much, Ange, and thank you very much, Alison. That's so interesting. Really enjoyed your talk there.